Good morning from New York, and a good day to everyone in the UAE and from anywhere else around the world. I am Ronald Jansen. I work for the United Nations Statistics Division in New York. And my office, one of the main functions of my office is to support the United Nations Statistical Commission, which is a gathering of all of the chief statisticians around the world of the community of official statistics, which determines together about international standards on official statistics, about international recommendations, best practices, capacity building, as a collaborative work through the UN. And that statistical commission in 2013, 2014. So the chief statisticians thought that our community, so the community of official statistics, needed to do more on big data, needed to do more on new technologies, needed to be more involved with all the possibilities given by digitally available data. So in 2014, the Statistical Commission established a committee, which is now called the UN Committee of Experts on Big Data and Data Science for Official Statistics. And the mandate of that committee was to provide a strategic vision of a global program on big data for official statistics and to promote practical use of sources of big data and find solutions for methodological issues, legal issues, privacy, data security, and so forth. And also then to promote capacity building around that, while trying to keep the public trust in the work that we as a community are doing. So when this committee started about 10 years ago now, it created several task teams. There was a task team looking at Earth observations of satellite data, how that could be used for official statistics. One task team looked at the use of scanner data in price statistics. And then there was one task team which started at that time already on the use of mobile phone data for official statistics, and where it could be used and how it could be used. So at that time, around 2014, we also organized a first global conference on the use of big data for official statistics. That was done in October 2014 in Beijing. And already at that time, we had presentations on this work of mobile phone data. And in fact, Positium, I think Positium was certainly there. Marcus Tiro did a presentation. The Flowminder, I think, was also there. So two of those who are presenting today were there already in 2014. Then in 2015, we had the second global conference, which was in Abu Dhabi in the UAE, in the United Arab Emirates. And it was also to indicate that UAE has been part of this journey on using big data for official statistics also right from the start. And on that journey, the United Arab Emirates was present in a lot of the activities that we did. And they also, in that context, wanted to do more on capacity building and having an influence for this kind of work in the Middle East and North African region. So in March 2020, the regional hub for big data and data science for official statistics was established in the UAE, in Dubai. That regional hub has done many things, and what is done today is, I think, the second webinar in a series of webinars that the regional hub is organizing, which showcases all the different work that this committee of experts is doing and how that can also then be broadcasted, be shown through the regional hub. It also shows the kind of work that is being done, the kind of possibilities of work that can be done, and also the kind of activities that can be shown through the regional hub in UAE. So today, and I will leave that more to Esperanza to explain the content of the webinar. But what I wanted to say is that the importance of the use of mobile phone data is widespread. So we've done this, we've used it for, you will hear about this more by the experts on tourism statistics, on migration, on population, transport, and disaster and displacement of people. So it's a lot about how mobility, or how there's human mobility, and how mobile phone data can help in showing this. And this was especially very important during the COVID pandemic, so in the beginning part of 2020. And a number of statistical institutes was at that point already involved in showing how mobile phone data can be used effectively in an emerging issue. This was done in Estonia. It was done also like in Ghana and Gambia and some of the African countries. So that showed how the mobile phone data could be applied very quickly. So I'm very looking forward to today. I wanted to just put on everybody's radar one event that will take place in Dubai in person, and this is in January 2024. It's organized with the Road Transportation Authority of Dubai and with the FCSC, the organizer of the webinar today, so with the regional hub of UAE. And that will be about data science and the use in the transport sector. And there will also be an event on the use of mobile phone data for transport statistics. So that's coming up in January. But today, I will hand it over now to Esperanza, who is leading the task team and has been leading this effectively for several years. And she will, I think, very proudly show all of the work that is being done. Over to you, and I wish everyone a very fruitful webinar today. Thank you. Bye-bye.
Thank you very much, Ronald. And I think you've provided really a very good snapshot of where we started and some of the work that we've been doing. Today, what I'll show you is the work that we've been doing with regards to mobile phone big data, and provide you some information on the different activities, as well as, can you see my screen just before I start?
Yes, we can.
Okay, just to confirm that you're seeing only one screen.
Yes, if you can put it into maybe presentation mode.
Done. Okay, that, can you see it now?
It's not in PPT mode, but we could see it. Oh, now you've disappeared.
Okay. How is it? Okay, can you see
No,
my
not yet.
screen now?
No.
Sorry, some technical issues here. Okay, I'm repeating it again. Can you see it now?
No, SP. Let me see if I've got it and I can note it on. Hold on.
Yeah, the sharing stop. Okay, so while we are fixing the technical issue, let me just try again. How about now? Can you confirm
Perfect.
if you can see my screen? Okay.
Yes, perfect.
Yes, so just to mention that the task team, as Ronald mentioned, started a while back, And since then, we've been working on several topics as well as methods that countries can use whenever they want to use mobile phone big data. So I'm not going to provide a lot of information on this, but just to mention that the mobile phone big data task team is one of the many task teams in the UN Committee of Experts. There are also on satellite, on scanner data, on privacy preserving techniques, on training and capacity building, as well as on big data for the SDGs. So we are one of the many different areas of big data where methods and capacity building is being explored. So in terms of the membership, so the task team has been working on with countries as well as international and regional organizations as well as experts who are leading in terms of the implementation of mobile phone big data use cases. And here our main objective is indeed to make sure that methodologies are available and that the data that were derived from mobile phone big data sources can be comparable at the international level. And so for example, UAE and some of the Arab countries are also very active in this work, as well as Flowminder, Positium, UNESCOA also joined recently. And of course, we are also joined by other countries from other parts of the world. So we are here, what we are making sure is that the methods that were put together can be applied in different country context. So just to go in terms of the different work that we do. So we had separated the work into different subgroups. And the idea here is to look at the different areas of statistics where mobile phone big data can be used. There is one on tourism statistics, which was led by BPS Indonesia, migration statistics, which was led by Geostat in Georgia, census and dynamic population, which was led by Positium. University of Tokyo led the work on displacement in disaster contexts. ITU led the work on information society indicators, and ECE and the FCSC, UAE, and RTA led the work on transport on commuting statistics. So this work that has been going on almost for the past few, I would say almost 2 years, concluded with different methodological guides. And these guides were launched in November 2022. And just to give you an idea of how each of the guides are constructed, so we look at the introduction on why it's important to use mobile phone big data, some background work that has gone into this type of new data source, as well as an elaboration of the work that is related to how data could be accessed and processed. Some reference data that's needed to analyze the mobile phone big data. So for sure, you need to have some reference data to verify whether the mobile phone big data is giving you the same result as for example, the household survey data. How the data can be calculated and the rationale for, why do we need to calculate those indicators, as well as quality assurance, which is very important for us to ensure that the data that we are using is of same quality as the survey data, for example. And then we also included some use cases, which you will be, for example, seeing in today's webinar. So this is an example again on information society. So all these materials, all these guides in different areas are available in the wiki of the UN SD. So you will be able to get access to this after the webinar. We also develop an awareness raising course, which is available in the UNSD learning platform. The link you can find there. And we also made this available in the ITU Academy. So countries, national statistical offices, regulators, and ministries have access to this learning course. And you will be able to find more information in the presentation of Thomas later on. So we've also done a number of events. Here we are showing only from 2020, but this work, as Ronald mentioned, started way back since the 2014. And recently, our focus mainly is on disseminating the learning materials as well as the different guides through events such as this. So we will be organizing more regional hubs, events, awareness raising course, and webinars to disseminate this information. But what I want to also point out is, there's really a big demand on using this type of statistics, but one has to understand that there's always some limitation which is related to access to the data. And this is a challenge that most countries experience in terms of using this new data source. So what I want to emphasize is the importance of coordination between the different stakeholders. So important to work with the National Statistic Office as well as the Data Protection Agency and the regulators, telecom regulators, and ministry. There's also a need to improve capacity, infrastructure in national statistical offices, and this we would like to also emphasize that coordination is sometimes the key to addressing these issues. There's also the guides that we would like countries to use when implementing projects and use cases to make sure that the different methods can be applied in different areas of statistics. And it's also important that data processing pipelines is in place so that these multiple areas of statistics and the different guides can be implemented using one data access. And in terms of the way forward, the task team is now looking into publishing the last guide, which is on transport statistics, which RTA UAE is leading. And we hope that this material will be available in a month or so in the wiki together with the other materials. The training materials, we also want to elaborate more and look at training materials that can be used by project managers and data scientists. And we want to also collaborate with other regional hubs in terms of disseminating the materials that we produce through these webinars and capacity building workshops. And we hope also to provide algorithms, Python codes to help NSOs to work on this new data source. And of course, the synthetic data work that is currently ongoing, this is also being led by RTA UAE. And the idea here is to have some synthetic data that NSOs can play with to learn in terms of how MPD could be used in different areas of statistics. There's a lot more that are available in these two links, and I invite you to look at those information after this webinar. And of course, there will be presentation highlighting the different use cases. So I stop here and I pass the floor to the next presenter that will provide information with regards to the different use cases, and that will be Sim. Sim, over to you.
Hello. Good day to everybody from my side. Thank you, Esperanza, for the introduction. Yes, it has been quite a journey to put all these guides together. And I'm giving you the overview of the guide on mobile phone data for dynamic population mapping. So this guide is kind of the foundation for all of the other guides, because population data is the foundation for many of the statistics. So I'll go first, but I want to let you know that this guide has been worked on by many experts, and it also stands on the shoulders of all the case studies that we went through to put together these guides. And you can see the experts named here below. And of course, we also very much appreciate all of the comments done by United Nations Statistics Division on the first drafts. So what does dynamic population mapping mean? What does the dynamic population mean? So do you actually know how many people live in your city, or how many visitors your city gets, and how many people are in your city now? We used to have walls around cities, and we used to know exactly how many people are there. Nowadays, it's like all the world is in a move. On the other hand, to develop the world, you need faster decision making, faster than ever, and decision makers need data in greater detail, and they need it fast to make decisions on utilities, operational decisions, as well as planning decisions. So new requests are coming in to have more dynamic population data. So what does modeling this reality mean? How can we actually make a model of this dynamic reality and show it in the way of statistics or points on a map as it is? So what are the challenges of the current population methods and why they might not be a good fit for this dynamic world? Although use of census and use of registries is widespread, and there are countries that are operating with very large population housing census every 10 years. These cost sometimes upwards of billions of dollars. There are countries that have access to good registries that are using these for population statistics, but of course they all have their own challenges which need to be met at the moment. But let's see if we can use new data sources to alleviate some of these challenges. So dynamic population mapping from mobile phone data aims to answer how can we map in a dynamic way without being dependent on the logistics of surveys or the census. And on the other hand, how to map this population that is behaving in a dynamic way. So understanding the de facto presence at any time, even if people are away from a place of residence. So two different perspectives. And the result should be that for any area of your country, of your city, we have a complete overview of how many people are there, how many people are residing there, how many people are working, transiting on a tourism trip, or just passing through. And how to make connections between these different places. One place is a home of work for some people, the other is a home the place of work, and the other is a place of home. So commonly, the definitions that we use for population is one is de jure population, which means we map presence of places of residence. So we can do that also with mapping the place of residence of subscribers in a geographical area. And then on the other hand, we have de facto population, and this is the dynamic part, which is mapping or measuring the presence of subscribers at all times in a geographical area. So two different concepts here in the dynamic population mapping guide. Now, these concepts, once you are able to measure them, they have several use cases for how mobile phone data can be used for population mapping. One is mapping resident population. Second is daytime or worker population mapping, then putting it all together and adding other segments, all of the population density or de facto population. During COVID-19, population redistribution happened and caused by mobility restrictions. Monitoring that and any kind of redistribution when it comes to any kind of outside effect, for example, for disaster preparedness planning. Infrastructure and resource planning, planning for utilities, planning where do you need to have resources at any given time, so to be ready for anything that happens, for law enforcement planning, for emergency service planning, but also utilities. And for the statistics office, actually having a dynamic source for sample frames for the surveys. For example, how do you identify who is going on an outbound trip and creating a sample survey from that behavior and targeting directly that behavior with the survey. And then an example of that is how MPD can be used for census. So I'll give you some examples. Resident population. When you measure the population of residents from mobile phone data, you not only get the number of people in a place of residence, but you get this dynamically over time. So you might tell where a person's place of residence is over the years period, and this is good to understand the usual place of residence. But then you can also go in and see seasonal trends of people being at their place of residence, or the second or the third place of residence, and how that fluctuates month by month, which is what we have here. The capital of this country, Estonia, it loses 25% of their population in July because people are going on holidays and they actually move out of the city. And data and population, by using mobile positioning data, cleaning and processing it, and detecting work time anchors, you can use other data sources, reference data from the building layer to aggregate this into where are the workplaces and where people are at work at any given time, at any given month. And then, of course, the big thing is having a census. So opportunities exist to complement the census during census preparation and execution. So establishing survey frames, also between the census periods to improve population projections, and measuring possible undercounted populations, for example, nomadic populations that are hard to reach, or adding features. So you do the census in any way it's possible through the survey or by using the registries, and then you add features from mobile positioning data to understand work time population, migration patterns, or commuting. And then bringing this all together, and this might sound like the future for you, is to carry out census through combination of technologies that could provide an innovative way forward. When you don't have good enough administrative data, combining it with big data to cross-validate and providing the best of both worlds. So it might enable data-driven census for countries that don't actually have good administrative data at the moment. And of course, there are methodological challenges. The guide goes through some of these. How do you build the right model? How do you model population density? How do you scale up to the general population to representativeness? And how do you validate the results? So there are different choices of models you can make. You can go a simplified route by directly from the raw data, but the most useful cases in official statistics have built a model of reality for each subscriber. And this data model is using statistical concepts. They're applied in early stages and late stages of the data processing, but you're building a sign of life or a story for each subscriber, and then applying whatever you need out of that for statistics. And I'm saying this because place of residence algorithm really matters. There is a study done in France that went through many different place of residence or home detection algorithms, and it turned out that what algorithm you choose could change the result by up to 40%. And this is on average. Consider how much of the result actually matters inside a specific region. Actually, some of them were 90% different from one algorithm to the other. And of course, you need to do validation of your home detection algorithm. And there are many cases where this has been done on the aggregate level, comparing census data with mobile phone data, and with very good results. Then you can also do it with individual data. For example, this is a volunteer panel that was built by Statistics Estonia. So we took the algorithmically determined homes from mobile phone data, and the actual homes that the volunteer panel have determined. They have said that this is their home. Also cross-referenced it to registry data, and we saw the differences, we saw the similarities. There were more similarities than differences. The differences were most of the time people not understanding the question, and they say what their home is based on what they feel, and not based on where they spend most of their time. So it's up to definitions as well. But algorithms have proven to be very, very successful. So that's a brief overview, and thank you. Please look into the guide for case studies and ask me if you have any questions about this.
Thank you, Sam. I think we are now, next one is Ayumi. Ayumi, please.
Let me share my screen. Can you see my slide?
Yes, we can.
Yes.
Okay, thank you very much. So today I am presenting the methodological guide on displays and disaster statistics using mobile phone data on behalf of the subgroup. I'm Ayumi Arai with University of Tokyo. So through the presentation today here, I would like to answer the following questions. Why are these statistics using mobile phone data needed? Why are they useful? And how they are generated and used? And how can we start and implement the project? And by the way, I listed the number of the institution organization who are working as a subgroup member. This is led by University of Tokyo, also including Flowminder, Indian School of Business, IOM, ITU, Positium, and others. Okay. So before starting, I would like to mention, what are these displays and disaster statistics. So when we say disaster, there is a definition by United Nations. And in this guide, we focus on statistics and population who are affected by all kinds of disasters. It includes natural disasters such as flood or earthquake, and also the health hazard such as COVID-19 or other infectious disease like cholera or malaria. So why the mobile phone data are needed for displacement disaster statistics? Because there are increasing policy interest in measuring the hazardous event and affected population. And timely and quality information is really crucial for disaster risk reduction and also disaster risk management. So National Statistical Office play crucial roles in responding to such data demand. That is the background. And then why these data are useful. So as you know, mobile phone data is relatively higher population coverage compared to the survey data. So it can trace a large population at the various scale of time and space. And the data is frequent and granular, so can capture the quickly evolving situation in timely manner. And once the data access is granted, there is less logistical constraints for data collection because the data is already collected by third parties. So I would like to explain about in the methodological guide, we describe the steps for responding the data demand I mentioned through the use cases where we highlight not only the methodology for computing statistics themselves, but also significance of pre-existing framework and infrastructure, because they facilitate a timely response and it also enhances preparedness and response capacity. So I would like to start with the importance of the institutional framework, because it enables us to establish, it is very important to have established partnership among stakeholders. And also it is important for secure data access. And it is very important to discuss policy relevance of using mobile phone data for displacement disaster statistics, because this is a project implemented by a government. So once the established frame partnership are established, we also need to be the data pipeline. In the data pipeline, the data never leave the country, because usually the data is processed under the premise of the regulator or mobile network operators. And in the data processing, data protection measure is taken. So we comply with legal framework and make sure that no individually identifiable information is included. And before producing the statistics, we also do data quality assurance, so that we can make sure that we can get quality statistics from mobile phone data. So we examine the validity of data for the analytical purposes. And once the data quality assurance is done, we produce statistical data and also do analytics. So we produce statistics on displacement or relocation and changes in mobility for these topics. And the data is ready, we disseminate a result and share the results and outputs with end user and other users. So our hand guide consists of more than almost 20 use cases, and all these use cases are following the structure I explained here. These implementation of mobile phone data project, and today I will introduce 2 use cases explained in the guide. First one is a country case 1, Haiti earthquake in 2021, implemented by FlowMinder. FlowMinder is presenting the other subgroup later. So there were a long-standing relationship between the FlowMinder and Digital Haiti. Digital Haiti is one of MNO. So they have been working almost more than 10 years for other disasters like earthquake, hurricane, and cholera and COVID in 2020. So there were already a pre-existing data pipeline which use FlowKit. It is open source software for analyzing mobile phone data. And because the system was already in place, they employed the existing framework to rapidly produce initial mobility aggregates. And in the process of the mobile phone data, they anonymized and no personally identified information was included. And of course, the outputs are aggregated and shared with end users. And they comply with the EU GDPR and data process on Digital Haiti premise. So data stayed in the country as we do in other countries. This is an example of output of their project. So this is an example to measure the displacement, a percentage of population relocated. So they computed the changes in population counts as a percentage of pre-earthquake period. And you can see that the red dot indicate a decrease of population, and the blue dot indicate the increase of the population. The second country case is impact of mobility restriction due to COVID-19 in the Gambia. So in the Gambia, they also have an pre-existing partnership between GBOS, National Statistical Office, PURA, the regulator, and 2 MNOs, World Bank and the University of Tokyo for internal migration analysis. So they have been working on the different topic before the outbreak of COVID. So they also have analytical pipeline at the time of the COVID, and code was already there. So they utilize the code and an analytical pipeline for computing the World Bank COVID-19 mobility indicator. So they anonymize the data and aggregate it, and they use privacy preserving technique that is reviewed based on a legal framework, because they don't have data protection agency explicitly in the Gambia. So we formed the committee to review the relevance of privacy preserving technique in the Gambia based on legal framework. And the data was processed on the premise of PURA, that is a regulator in the Gambia. This is also the example of the measuring the impact of activity level computed by using mobile phone data. It indicates a daily, it actually computes the daily distance traveled by different locality. So it indicates a percentage change of the activity level. So if it is below the line, activity level is lower than the pre-COVID situation. So you can see that the large city has a shorter and less impact due to the restriction, mobility restriction, and the smaller villages where relatively fewer people are concentrated had a larger and a relatively longer impact due to the mobility restriction on their activity level. So in the summary, I would like to highlight three things. One is that besides the methodological framework for computing statistics, institutional framework and analytical pipeline is very important because it enhances preparedness and responsive capacity under disaster. And it also accelerates the use of mobile phone data. And secondly, securing data access remains a challenge. Is true. So under disaster, sometimes alternative data sources are made available by the private sector. So it is also one way to try using that data in disaster situation. And it also can be a proof of concept and also help the discussion move forward to realize the access to the data in some countries. And thirdly, innovation in analytical method is still needed to improve the robustness of estimates of sparse mobile phone data. So although we have good methodology for computing mobility statistics for mobile phone data, we believe that it will be improved more in the future. So this is the end of my presentation. Thank you very much.
Thank you so much, Ayumi. And now we are going to get a presentation on tourism statistics from Fatina Reno from BPS Indonesia. Alpha, floor is yours.
Yes, thank you. Wait, let me prepare my screen. Wait. Did you see my screen?
Yes.
Okay. So, thank you everyone. At this moment, I'm going to present unlocking the potential of mobile positioning data, collection, processing, and challenge. But before that, you can find the methodological guide on use of mobile phone data for tourism statistics from the UN Statistics Wiki. Okay, maybe I'm going to show you how Indonesia follow that handbook to process tourism statistics. We start the journey with initiative for using MVD in inbound border. And then right now we already create a lot of case based off the using of MVD. We try to find how tourism pattern within the district, so within the city. Also from the handbook, you will learn about how MPD looks like. a trip is defined as a journey from one usual environment to another. As Sim mentioned before, that it's important to define your definition of usual environment. So from the mobile phone data, you will have like this pattern. You will have timestamp. You will have longitude and latitude, and then those longitude and latitude you can convert to your local administrative unit, and then you can learn the movement from the MPD and create some pattern and explain the pattern, whether it is a usual environment or tourism. So from this data, we can see that a lot of trip has been made from Jakarta to Tangerang to Lombok Utara, Lombok Barat, Lombok Tengah, Lombok Timur, and back again to Jakarta. And then you will find which one is movement and which one is only for passing by. A lot of methods have been used for defining usual environment. In this slide is actually the basic that the basic concept of tourism is the activities of person traveling to and staying in place outside their usual environment. For Indonesia case, we define usual environment in some place like home, work, or a place for activities. Second homes, we define home and work if it's different city as a commuter, and also the movement between city that occurs monthly or weekly or circular. From the UN Wiki, you will find that there are two types for defining usual environment, using anchor position and using cluster. And for BPS case, for Indonesia case, we use the anchor location, and we will develop our own algorithm, and we declare it's on the algorithm. So after you define usual environment, and every trip outside the usual environment is declared as tourism trip. While processing your tourism, there are some routines that you need to check, like for the quality assurance. Here we have 2 points for quality gates, for the data input and also for the data output. So you collect the data first and then check whether the data input is good enough to through the processing, and then the calculation, the algorithm, and check for the output. After you confidence with everything, then publish. If you want to know more details about KF, actually the handbook is already mentioned some dimension of quality, but we try to put it in use case for with the statistic data in here. So, for official statistic, actually, for tourism case, we cannot get everything from mobile phone data. From MPD, maybe you can get the origin, destination, length of stay, and length of journey. But compared to the conventional method, we also need purpose of trip, demographic, expenditure, and modes of transportation. You can combine actually MPD with digital survey to get all those kind of statistics that you need for your tourism statistics. This may be what I highlight with the using of MPD for tourism statistic, why Indonesia slowly but sure leave the conventional survey for tourism statistics and move to MPD approach, because with MPD, we can estimate for smaller area or district and cities. Right now, in this year, Indonesia start to learn how to measure the tourism statistic in the city. And from yearly data period, we can make it monthly data period. We also no need to recruit surveyors anymore with MPD, and also with smaller budget. Actually, when you yes, we do procurement. We do have a scheme of procurement with the data, but with the smaller amount, we can get more the data is more small in a smaller level. It has the potential to be able to generate statistics for domestic tourism monthly, and also we still can provide tourism statistics during the pandemic because yeah, we do not need the survey again. And also with MPD, we are not only providing for tourism statistic, but also dynamic population, also migration. We can provide it with MPD. Like you have one data and you can create a lot of case from there. Wait. Sorry. I think something wrong with my slide. Wait. Can I have take a break because it's azan in my place?
Sorry, Alpha, you wanted to...
No, it's azan, and here in Indonesia, if we hear azan, we have to break for a while.
Okay.
Only for a few minutes.
Okay, so I think we can pass on the next presentation to Frederick. And then maybe Alpha, you can join afterwards.
Okay. Thank you.
Thank you. Frederick, over to you.
Thank you so much. Can you see the screen? Yeah?
Yes.
Perfect, thank you. Yeah, hi, I'm Frederick. I'm a data scientist working together with Esperanza at the ITU. And I will just briefly showcase some of the applications of using mobile phone data to improve the measurement of the information society. Now, first of all, in a way, mobile phone data is the information society. And if we had access to all the data generated through the applications and through the mobile networks, our jobs would be much easier. But this is obviously not the case. The data is owned by many different actors and not even looking at the regulations to ensure the privacy protection. But there are some good use cases where data from, for example, call data records and the mobile phone networks can really be useful to add value to the measurement of the information society. Now, the first area, for example, is internet connectivity and mobile phone usage. How many people access the internet using their mobile devices, where, when, and by which technology. Or internet use is one of the key SDG indicators, and normally it's collected through household surveys. But there are many countries which do not necessarily conduct household surveys on a regular basis, and where data on internet use is quite limited. So this is an area where mobile phone data can be very useful. Another area is mobile network coverage, which is also an SDG indicator. Now, countries report the proportion of individuals with 3G, 4G, 5G coverage to ITU, but this information comes from operators themselves, and it's sort of only reported at the national level. And calculating the mobile network coverage using mobile phone data provides an additional check and also can show the coverage with much finer granularity than the aggregated data. A third area, which also has been explored in some of the earlier mobile phone pilots, is traffic. For example, the CDRs include information on the call, SMS, and data events, which also can be used to better understand sort of the average mobile phone usage of the population. Just to go a little bit more detail on this, if we start with the proportion of the population using the internet, as I said, a very key SDG indicator. Now in Brazil, the Brazilian Institute of Geography and Statistics used mobile phone data to determine the number of users accessing the network using different technologies, and that way get a good proxy of internet use in the Rio de Janeiro area. By looking at the user patterns of each subscriber over time. The home location, which also was described earlier by Sim, for example, a home location could be assumed for the most subscribers. And it was then possible to determine the share of subscribers with internet data traffic by the different network technologies for each of the municipalities in the Rio area. The results were also compared with data on internet use from the Continuous National Household Sample Survey and had very promising results. The mobile phone data were in line with the results from this survey. So this is one indicator where mobile phone data can be quite used. Another one is the other SDG ICT indicator, which is the proportion of population covered by a mobile network. Now, this is an example from BBS Indonesia, where data on the location of cell towers were used together with information on geographic elevation and population data to estimate the share of the population covered by the different network technologies. Now, the elevation data is, of course, important to determine the reach of each cell tower using, for example, the line of sight. If a cell tower is located in a valley surrounded by mountains, then even if the other side of the mountain is quite close, it cannot be assumed that the signal will reach those areas. So while it's preferred to get the cell tower data directly from the operators, there are also some interesting crowdsourced initiatives. One example is OpenCellID, which manages a huge database of the cell tower locations that are being registered and automatically uploaded to this database using mobile phone apps by the users. And the end result here, for example, is a quite detailed map of the network coverage across the country. Now, another use case for this indicator is to use this information as a cross-check on the data provided by the mobile operators. Now, in this slide, this is, for example, 4G coverage in the Rio area in Brazil from the study in Brazil, both reported by the operators and observed through the mobile phone study. Now, for some municipalities, there were some significant differences. For example, one example here, I guess, was Mendes, where the 4G coverage reported by the operators covered most inhabitants, but this was not replicated in the mobile phone study. There could be many reasons for this, for sure, but it's a good check to perform. Now, other indicators that have been explored also in the past include, for example, traffic indicators. At ITU, we collect a variety of traffic indicators at the national level, but these are aggregated not only for the entire country, but also through all the different technologies. And using mobile phone data, it can be possible to get more granular information. Also, for example, the type of technology that is behind the traffic generated, whether there are any differences across the country or over time. And in some cases also, it can be possible to actually segregate the traffic by the type of usage. For example, different OTT services, perhaps like video streaming and so on. Now, these studies in Georgia and UAE were done many years ago in 2016, 2017. And even though the 4G network was well developed in the UAE at the time, you can see that actually a lot of the traffic went through the 3G network. Now, another traffic indicator is the outbound roaming traffic, meaning not necessarily the tourists coming to your country, but how much traffic the user generates abroad. And the differences seen in these two pilots could perhaps be also related to the differences in international roaming prices or whether people actually buy the local SIM cards when they travel abroad instead of using their domestic SIMs. Mobile phone data also creates sort of new opportunities to develop for new indicators that we do not collect for the moment. One example that was also explored in the earlier pilots is the activity rate of subscribers. Now, these days, I mean, people may use the cell phone on a daily basis, more than here. But the pilot, for example, that we saw in 2016 was that only 47% of the subscribers in the UAE actually used the subscription daily. Maybe this also can be explained by users if you have multiple SIM cards or multiple phones and you're not using the same one every day. Another promising indicator is actually the type of device used. And these shares were determined by looking at the International Mobile Equipment Identity, or the IMEI number, which is a unique number for each device that has also been used, that you can use to perhaps block your phone if it's been stolen to get into the operator network. But the first 8 digits of this code is also known as the type allocation code, which identifies the model and the producer of the phone that is being used. So if this number is available in the data, then you can get a much better sense of the phone market and which devices are actually being used in the network. And this could be interesting, for example, if looking at not only if launching new services or apps, but actually to understand the reasons, for example, for non-usage. For example, if there is great coverage, but there might be an affordability issue if most people actually are using old traditional mobile phones. This example back in 2016, we could see that already at the time there were more than 50% in the UAE that used smartphones, while in Georgia it was 1/3. So far, ITU has been involved in 8 different pilots since 2016. They're listed on this site, and also there are some of the country reports available on the website below. But there's also been I would say almost a surge in interest from several countries. So hopefully we will see more interesting use cases in how we can use mobile phone data for the information society in the near future. Thank you very much, and I'll get back to you, Esperanza.
Thank you so much, Frederick. So I think we are now, if Alpha is ready to go back to the remaining slides,
Yes.
Alpha,
Okay.
over to you. Thank you.
Thank you. Sorry for the disturbance. Wait. Okay. Yeah. So this is what I've presented before, that now from 2019, Indonesia already have statistic for domestic tourism for monthly statistics. Previously, for domestic tourism, we only have yearly statistics. And also we can also provide how the pattern from inbound in our super priority destination Indonesia. It's only a small region. Super priority destination actually how we implement MPD to find visitors in a certain area. So we can find from 5 super priority destination how many visitors that come from different countries. But actually this had a little bit problem because the original country comes from the number of their smartphones, not from their real original country, because we translate the code into country of origin. This is the challenge using MPD for tourism statistics. First, for the data itself, I think it will happen for every case. Intensive discussion are needed with the mobile network operators regarding data usage. But if you have a strong connection with one operator, of you already established an cooperation with one mobile network operators, maybe the other mobile network operators will follow. Like what happened in Indonesia, we start with only one mobile network operators, but since last year, we already work with the 3 largest operators in Indonesia. The second problem is standard data, because all the operators have different format of the data. So we already mentioned in the handbook of tourism statistics, maybe we can ask the operator to use the same standard data, so it will be easier for us to implement the algorithm. Or yeah, we can try to match our algorithm with their data, but still keep with the standard. And also for the data characteristics, you really need a deep dive to the data to find anomaly, accidental roaming, or any pattern that not included for the analysis. I think this is the challenge with using mobile phone data for not only tourism statistic actually, but for every case. Okay, maybe that's what can I share with you with using MPD for tourism statistic. Back again to SP. Thank you, SP.
Thank you so much, Alpha. Very interesting use case. Now we are moving to the transport and commuting statistics. So it will be presented to us by colleagues from RTA UAE, Dr. Raj and Bijit Deb. So I pass the floor to the two of you to share your experience and the use case on transport. Over to you. Thank you.
Thank you, Renee. I hope you can see my screen.
Yes.
Okay, all right. So we had very interesting use cases of mobile phone data in a lot of different areas, including tourism, including people movement, etc. So in this presentation, we'll be covering some of the applications of mobile phone data in transport and commuting. And myself, I am Raj Kamlanath Sharma. I'm a Chief Data Scientist at Roads and Transport Authority, Dubai. And I'm joined by my colleague, Bijit Deb. Is our data architect from RTA as well. So I forgot to put credit slides like others, but let me give the credits to our task team. All of them contributed by providing case studies, by providing feedback, comments, and even some revisions to make our handbook pretty exciting. So as a quick status update, our handbook is not out yet. We are in the final draft review stage. But just to give like a trailer, it was focusing more on the transport related use cases and how mobile phone data can be used in transport itself. What are some of the applications and case studies from around the world? So this is actually the second handbook. There was an original handbook in 2019, which focused more on the technical aspects of how to process the data, what are the considerations related to call detail records and so on and so forth when it comes to gathering mobile phone records. So with that in mind, I'll be speaking for most of this presentation, but before that, I want to take a step back and just give an overview of what are the different types of transport applications of mobile phone data. And if you look at this slide, it shows, I would say, from left to right in increasing level of complexity in some aspects, but decreasing level of complexity in some other aspects. Yeah. So the first one, statistics and reporting. So here, the good thing, as others mentioned, is that just like population statistics, transport statistics can also be derived from mobile phone data, specifically from population density and people movement data. These are the two categories of mobile phone data. But since it's statistical data and reporting data, most of the data is easier to obtain because it's aggregated data. And some of the examples are census, transport statistics like personal miles traveled, trip time, average trip time, origin destination metrics, etc. So that's the first category. The complexity here is that because we are going to use the mobile phone data in statistics, the accuracy is of importance. So some of the techniques that my colleagues mentioned related to comparing mobile phone data generated statistics versus census generated data statistics, these kind of techniques should be used before using mobile phone for statistics. The second area is reactive decision making, which is, again, most of the transport agencies do in terms of short and long range transport planning. So here, again, the good thing is that you only need to use historical mobile phone data. In most cases, we do use aggregated data, but it needs to have some sort of segmentation associated with it. And by segmentation, since it's a transport-oriented usage, we basically tag attributes to mode of use, which is whether it's a private car or a public transport, etc. And the handbook talks about how this kind of external attribution can be done by using point of interest and all those things. The third and more complex usage is real-time decision making. So here, the idea is that we'll use mobile phone data to understand where the crowds are and how to dissipate the crowd. Was it higher than same day last week or same season last year, etc. So the applications here are event management, traffic management, incident management, etc. So again, here we can use aggregated data, but again, some sort of segmentation is required so that we can take that valuable decision. The last one is predictive application. So for example, we can have incident prediction, traffic prediction, etc., where we use a mix of historic and real-time data sets. And here the main challenge is the latency for mobile phone data, depending on where you are and the regulatory authority. It can be anywhere from 15 minutes to hours. Yeah, so this is still in a nascent stage. Some of the larger event management across the world, like for example, Expo, etc., did some of the predictive applications around this. Now, going into a little bit more detail, we will talk about like 8 different applications which are more specific. So the first 2, which is the transport and statistics, reflects the previous mapping. So here, the idea is that mobile phone data can be used in identifying origin destinations of trip, modes of transport, population density, trip rates, model split, etc. Traffic characteristics such as identifying congested areas, average speeds, vehicle miles traveled. So again, some of these statistics require a lot of validation with the ground truth, but some others, the only thing that we need to validate it is it's a comparative study. So for example, we'll be comparing it with last week. The same day, was the congestion higher or lower? So here we don't, the actual number of vehicles may not matter that much. So for example, if many cities now people have 2 or 3 SIM cards, so things such that like that will be normalized across the different use cases. The third and the fourth use case, it's mostly in planning. So one of them is transport and urban planning, which is again requires some sort of mode detection so that we can identify what is the travel time using bus versus using car. What are the some of the black zones where people are unable to reach by car faster, even though geographically it's close by. Which are the locations where we have specific commuting patterns, northbound, southbound traffic, or eastbound, westbound traffic during peak hours, etc. The fourth one is the same, but with respect to public transport planning. So here, again, here the mode detection is to some extent, when it comes to public transport planning, the mode detection is easier because we already have a fixed network of public transport stations and routes. So the attribution of mobile phone pings to those locations are easier. The last row, again, it's a bit more complicated. The first one is the traffic analysis, which I've already mentioned, but here the main idea is to use some sort of cluster analysis and understand what are the factors that impacts traffic, whether it's roadworks, whether it's accidents, congestion due to weather impacts, etc. So you'll be attributing not just mobile phone data, but external data as well. The fifth one is I think it's the sixth one is the operational decision support. So sure, you have seen at least everyone who's in transportation already knows this, but others must have seen in movies that almost all cities have operational control centers or traffic management centers that makes dynamic decisions based on where there are congestion, how to relieve it, where there are incidents, etc. So those kind of decisions can now be taken based on mobile phone people movement data or population density data. So that's the sixth one. The seventh one is events and crisis management, and this is a very popular use case, especially in larger events like Olympics, Asian Games, and even Expo last year in Dubai. The last one is traffic and transit prediction. So here the idea is to use some sort of varying models to assess is the traffic going to increase or decrease based on the forecasting that we can do based on mobile phone data. So that's at a very high level, the 8 different applications that we talk about in our handbook. Now we have 9 diverse case studies. Obviously, we don't have anything from the America. So if there are more use cases, feel free to send it to us from these locations. But as of now, we have these 9 diverse use cases. Now I won't go into each of them, but I just have one slide that shows some of the use cases, and most of them are studies or even statistical analysis. So the first one is from South Korea, how the mobile phone data was used in planning a night bus service. So the Korean Telecom used their pings to understand how much movement is there. So this, along with the taxi trips that are taken at night, gave them a baseline of what is the best night route, so that people or employees who have late night schedules, they can use these buses. The second one, I know we have a colleague from Indonesia, so she can explain it probably better. But the idea is to use mobile phone data in transport statistics, specifically in terms of household travel survey. So a large portion of the household travel surveys would be to identify the home location, work location, mode of travel, and travel time preferred, departure time, etc. So this their mobile phone data study actually replaced some portion of this household travel survey. The last one is from our own Dubai. So where we are actually, or we used the mobile phone data to optimize bus stations. So as you can imagine, major bus stations require a lot of walking from one end to the other. So we took one of the stations, which is in Old Dubai, which is surrounded by a lot of commercial activities, and understood where people from certain bus routes are going. So what is their final destination or their initial origin, so that we could reduce their walking by just reallocating the laybys within the bus station. So these are some of the examples. That's all from my side. If you have any question, we'll be happy to answer. Thank you.
Thank you very much. I think these are very interesting applications of mobile phone big data. There's quite a number of them for transport, so we are excited to see that the work is being explored in the handbook, and we are looking forward to more use cases on this area. So with that, I think you've seen all the different applications of mobile phone big data in different areas of statistics. So I think what's left for us to hear is the awareness raising course. This is a course that was developed with other members of the task team. And we have here today Thomas Smallwood from Flowminder to share with us the important product that we had released on this. Thomas, over to you.
Thank you. I'll just share my screen. Hopefully that is working. Can everyone see that? Can I get quick?
Perfect.
Perfect. Great. Yeah, so very happy to be here today and talk to you a bit about the work of the training subgroup and the e-learning subgroup on producing our first training course, the Raising Awareness course for mobile phone data. So today I'm going to quickly cover what the course is and what its purpose is. We'll take a look at the course structure, have an introduction to some of the learning materials included in the course, and then we'll talk briefly about some of the future plans of the e-learning subgroup. So starting with what is the Raising Awareness course? So when we put this course together, we had a few ideas about what the purpose of this course should be. We wanted to introduce some of the key concepts which underpin the use of mobile phone data. We wanted to highlight some of the main opportunities presented by mobile phone data for official statistics. We wanted to explain the strengths and limitations of using mobile phone data, which are important for understanding how it's used most effectively. And lastly, we wanted to also outline how someone goes about running a successful mobile phone data project and some of the considerations that you should have when starting out on a new project. But really, this all comes together for the overall aim, which is to support you at national statistical offices and other organisations to start your journey towards using mobile phone data for official statistics. So take a look at the structure of the course. There's three main sections to the content. The first looks at what is mobile phone data, and here we look at different types of mobile phone data before focusing primarily on call detail records. And we look at how mobile phone data, including call detail records, are generated, the types of information which is contained within mobile phone data, and then why would you use mobile phone data? And we look at the strengths of it, and we also look at the limitations of using mobile phone data. We then have a second section where we look at the applications. So this draws heavily on the examples we've already seen from the presentations today, but covers 5 case studies from different areas. So look at transportation, public health, disaster response, tourism, and information society. And then lastly, we have a section on how to manage mobile phone data projects. And here we look at obtaining mobile phone data, which is often one of the largest barriers to a new mobile phone data project, the requirements for work with mobile phone data, and perhaps most importantly, how we go about preserving the individual privacy of mobile phone subscribers when we're analysing data for a mobile phone data project. Once you've completed these 3 sections, there is then an end of course quiz and a certification as well, which we'll come to in more detail in a minute. So reviewing some of the content that's included in this course. So as I've said, the first section covers what is mobile phone data, and this covers pieces of information such as the types of mobile phone data, how it's generated, the information contained in it and its strengths and limitations. And here we can see one of the pages with some text and an explanatory diagram which covers how call detail records are generated and explains in hopefully an accessible way some of the basic information around the generation of call detail records. And then moving on, taking a look at the applications. As I said, we've got 5 case studies that we look at in this section. The first is commuters in Tartu in Estonia, based on some work by Positium. The second looks at the government response to a health crisis in the Gambia. Then we look at emergency response to an earthquake in Haiti. We take a look at tourism statistics in Estonia and Indonesia. And then we look at information society statistics in Indonesia and Brazil. And for each of these case studies, we break it down into 4 parts. First, outlining what is the situation in which the mobile phone data project was started, explicitly stating what the problem we're trying to solve with mobile phone data was, what the solution that was implemented looked like, and then what were the outcomes of this, what was the impact of using mobile phone data in this case study. And alongside the text, we've also got some useful figures which should help further demonstrate how mobile phone data was used in this context and the result of that was produced by this data. And then finally, looking at how to manage a mobile phone data project. And as I said, a large part of this and a significant topic for us to cover in this course is how do we analyze mobile phone data in a secure manner, and how do we do so in a way which preserves individual privacy. We discuss in quite some detail, but hopefully again in an accessible way for a newcomer to this area, some of the considerations for the secure processing of mobile phone data and how to go about it in a way which preserves the individual privacy of mobile phone subscribers. And finally, we have the end quiz. This will have, for each person will receive 4 questions out of a bank of, I think we have 12 questions, and you have to correctly answer 3 out of those 4 questions to pass, and you get 3 attempts. And if you do, you get a very nice certificate like the one you can see on the screen here. So having seen the certificate and understood a bit more about the course, I imagine the next question that everyone's asking is, how do you get a certificate for yourself? And as has already been mentioned today, you can now access this course through the UN Global Platform Learning Management System at learning.officialstatistics.org. To wrap up, I'd like to talk a bit about the future plans of the e-learning subgroup. I'm no longer chairing this group, but I'm still involved, and we have some exciting plans moving forward. So the next course that we're working on at the moment is going to be a more detailed look at how you manage a mobile phone data project, some of the barriers to using mobile phone data, and the different ways in which you can address those barriers and start a project up, the considerations for starting a new project. But we're also looking at doing some more in-depth courses related to each of the guidelines that have been published by the other subgroups. So looking at dynamic populations and censuses, tourism, migration, information society, displacement and disaster statistics, and transport and commuting statistics. But we would also really like to know what types of courses you would find useful. So if there's any particular training needs that you have, please do get in touch with myself or someone else from the task team and let us know the types of courses that you would be interested in us trying to put together. So with that is a brief presentation, but I'd like to thank everyone who's been involved in putting this course together, everyone who's contributed to the work of the training and e-learning subgroup of the mobile phone task team, and I'd invite any questions and any feedback on the course. Thank you very much.
Thank you so much, Thomas. I think we have now reached the list of people presenting the use cases and the introduction to the learning course. So we are now in the section in terms of your questions. So we are very excited to learn or to hear from you if you have any experience that you would like to share or any question you may have on the different use cases. I see that there are some questions already in the chat with regards to the presentation made by Sim. Sim, would you like to take the floor and maybe explain that in detail so that other people can also learn from the question on learning about the usual environment?
Yes, sure. I don't see the chat for some reason, but I saw the question, and the usual environment is something that really needs to be developed every time you do tourism statistics on mobile phone data. So there are a couple of approaches. We've been working on it since 2008, first time we did, or even earlier, we did user environment from MPD in Estonia, and then in other countries as well. Oman, Indonesia, you heard about it. And it's a crucial component every time you do tourism statistics, not only for domestic tourism, also for inbound tourists, because some of those inbound roamers are actually living in your country, and you have to understand their usual environment as well. And it links to the population statistics because, for example, our method for detecting the place of home for a person is to list all candidates for home, which are based on where people are regularly. And if you know where people are regularly, then you can start to defining the usual environment based on that regularity. And you can have more candidates in your usual environment or few. less of them, and you can define the usual environment as one district of the city or the entire city or the entire county or region. So many possibilities open up there.
Thank you, Sim. And while you are there, and maybe to other speakers as well, there was a question on how do you handle multiple SIMs? I think this is a usual question that we get from individuals who are interested on using this data. And I think Sim, if you can share how this is handled in the use of
from usual environment to usual questions. Yes, this is a very common question because this is definitely a challenge that you need to overcome from working with mobile phone data. Not only do some people not have mobile phones, but some people have multiple mobile phones. In Indonesia, they have phones in one network, 2 SIM cards, and then 2 more SIM cards from the other 2 networks. So you have to account for these, and you do that by thinking of the mobile phone data as a sample. It's a sample of subscribers. That sample can be 30% if you're using one operator. It can cover 30% market share or 50% of the population if you're using one operator. But if you're using all of the operators, you're looking at more than 100% sample size, and then you have to scale down your result. So what we do is we extensively link the mobile phone data results to any reference point, any reference point, meaning either a census point, place and a time, anywhere where you have data that you can link and understand how the number of subscribers actually is referenced to, compares to the number of people. And you can also have extensive surveys across the entire population to understand what is the usage of mobile phones, who has multiple SIM cards, and from which telco operator. This is an approach that Eurostat will now widely test out in Europe and with different European Statistical System network offices.
Can I add some details for this question?
Yeah, thank you, Sim. Maybe I can pass the floor first to Thomas and then later on to you, Alpha. Thank you.
Thank you. Yeah, I just wanted to add to what Sim has already said. This is something which Flowminder has been very actively engaged with recently. We've been working on combining the mobile phone data with census and survey data, including specific phone data, phone survey data that we've collected. First in Democratic Republic of the Congo, where we've been working. We've now also implemented it in Ghana, pairing up with Ghana Statistical Services on the census and adding some additional questions to the census to help us gather the data that we need for the BAS adjustment and population scaling of the mobile phone data. And we're very happy to say that we've now implemented the BAS adjustment and population scaling methodology that we've developed in Democratic Republic of the Congo. It's currently being implemented in Ghana as well. And we have another phone survey happening currently in Haiti, where we'll also be implementing the same methodology to address biases, which includes both the underrepresentation of some parts of the population who either don't have a mobile device or use it irregularly, and also the overrepresentation of others who perhaps have multiple SIM cards with either the same telco or with different telcos.
Thank you, Thomas. Alpha, please.
Yes. Great. Okay. Actually, I have this slide on this one because it is the frequently asked question when we are using MPD. What about those who do not use the phone, and what about multiple SIM cards? So in Indonesia, we still have our socioeconomic survey, and it was held once every semester. We asked this question in our survey. So we ask whether someone using or not using cell phone, have or don't have cell phones, and a number that they are on it, they are used. We use this to create a weight to then calibrate the model. So after the calculation has been made with MPD, then we apply this weight to extrapolate the statistics. Maybe if you still have conventional survey and you did it regularly, you can try this method. That's all, SV.
Thank you, Alpha, for that clarification. I see a hand from Husam Khalifa. Husam, would you like to take the floor? Husam, can you unmute? Otherwise, I can also see a question here that was written in the chat from him or her. The question is, can you elaborate more regarding the period of training courses? Thomas, would you like to take that question?
Sure. It depends what's meant by the period of training courses. I believe that the Raising Awareness training course, we've developed that it should be something you can complete in around about half an hour, depending on how much you want to dig into the additional resources that are linked to. But this isn't a time-consuming course. It's not a long-running course that requires you to schedule time on a regular basis. This is just a short course to provide an introduction to mobile phone data, and perhaps in future we'll have some longer running courses, but for now it's just a short half an hour to give yourself a good introduction to the basics of the use of mobile phone data.
Thank you, Thomas. And if I can just add to that, so the training course is available in the learning management system of the UN Statistics Division. So this is an open course as well as in the ITU Academy. And basically, there's no limitation as to when you can take it. It's a self-paced course. So as long as the training course is available, you can take it anytime. So this is not going to be, I would say, closed, but it will run until the end of the year, and will probably renew again next year, and will probably remain in the learning management system for quite a while. Thank you. So, and do you have other questions to any of the speakers? If not, Renee, are you still there? Can we maybe have an indication with regards to the survey that we've run in terms of exploring what are the other areas that people would like to see in the next webinars?
Okay, so just from my side, we only have 8 replies as far as the survey is concerned. So if I can ask, please, in the invitation email that went out, there was a short survey that was in there. If I could ask everyone to please complete it. This information will be of great value to the MPD team. So please, I will send the link out again when I send the email with all of the links to the YouTube channel and everything else as well. Also, yeah, so that email will probably go out on Monday, so please keep a lookout for it. So other than that, I'm just having a look. I don't have any other questions on the chat.
Yeah, thank you, Renee. And so, yeah, for the survey, please take your time to complete it. There's another question just coming up now. I'll read it. There is a limitation in mobile data. We can't know data about the demographic, economic background, and other indicators that you have got by traditional survey. Maybe I can take a stab on this question. So in the Information Society indicators that we recently look at, we tried to see whether we can calculate internet use, for example, with regards to gender and age. And this is possible if you will be able to link the CDR information with your customer management system or database. So this is possible, but you have to link two data sets to be able to get this information. And I invite other speakers if they want to comment on that. I don't know, Alpha, have you tried getting this data onto FreeSem or SIM on the population?
Okay. Actually, demographic, economic background, and other indicators is not part of the mobile phone data, since mobile phone data is also keep timestamp, location. But if you manage to have a better agreement with your mobile network operators to have those additional data, since those data were keeping by were kept by them, it might combine their subscribers data with MPD. Yeah, but for Statistic Indonesia case, since they have the regulation of private data, we cannot access the subscriber data. Yeah, but we held the digital survey and asked them to fill the demographic part. So they give the consent to us based on their willingness. At the end, we have the information about the number and demographic background.
Thank you. So there you're highlighting the importance of good relationship with the mobile
MNO,
operators.
yes.
Yes. Yeah. There's a follow-up question, and I think this is also for you, Alpha, from Ahmed. He's asking regarding the ratios from household survey about the number of SIMs to estimate the penetration rate. And is there any discrepancy over that over time? And if so, how do you deal with this issue?
Yes, of course, Ahmed, because for domestic tourism, we always update the weight every semester. But for inbound tourism, we also calculate inbound tourism, which is we need to know the behavior for foreigner tourists who come to Indonesia, whether they change their SIM card or keep both SIM card while they come to Indonesia. So it's different with the domestic tourism. For foreign tourism, the last time we did the survey is 2017. So by time when we are trying to extrapolate the data based on the previous weight, it's getting weird and weirder. So that's why we will going to have the same survey again next year, because I think for foreigners, you need also to update the weight at least yearly, because yeah, they will be shifting in behavior and using mobile phone also in Indonesia.
Yeah. So I think that it's also dependent on the country situations, because in countries where the regulation is I would say implementing a better interconnection, then people will normally just own one SIM card.
Yes.
And so I think that is so really dependent on the market situation.
Yeah.
There's
Yeah,
another.
if I may come in.
Yes, please, Sim.
I think this question is very important because scaling up to have the use for mobile phone data, not only to get quick and useful indicators on a percentage basis, but to have full population, full numbers for statistics is very crucial. And to add to what Alpha rightly said, everything is correct. And then to add to that is you can have running indicators about how your weighting methods are being skewed, and if you need to adjust or do another survey by using any other data that you have, and always comparing the trends in the data sets. In Estonian Bank, since we have done the tourism and travel statistics since 2008, almost from that time, there's always been a running comparison by central bank to compare with credit card data, payment data. The country level statistics should be roughly in line in terms of trends, and also any comparison with accommodation data and any immigration data you have. So all of the data points that you can use, always use them and see if there's some divergence or discrepancy over time, as they asked.
Thank you, Sim. There's also one question with regards to the presentations, whether it will be shared with participants. So what we are planning to do is to compile all these presentations and put them in a location where it can be downloaded. This will be communicated to you by Renee. We will have to agree on a platform where it will be available and with all the speakers in terms of making these presentations available. But in any case, as Renee mentioned in the beginning, this session is recorded and it will be available in a YouTube channel, and a link will be provided as well. I assume Renee will be communicating that to you so that you'll be able to go back to the presentations anytime. So we still have 10 minutes left. I don't see any question coming in the chat. Maybe I can ask the speakers if you would like to add anything or comment, or Renee to maybe let us know with regards to future webinars, any interesting topic that you see that we could explore that will benefit the countries in the region. I think from the questions, I heard that this issue about underrepresentation or overrepresentation and scaling up weighting method could be a good topic to cover for the next one. But I open the floor to other speakers and to Renee to make their last interventions. Renee, please.
Okay, sorry, I'm just having a look at the responses that was received so far from the survey. The challenges that most of them had so far is just the lack of tools, infrastructures, lack of knowledge, accessibility, privacy issues. So, I think it's the general case that everybody is suffering from the same things. So, but what I will do is that I ask everyone if they can do it before Monday, and then on Monday I will collaborate everything and send it off to the team, and that should help you from there.
Great. Thank you, Renee. I think those topics that you mentioned are indeed, things that we can consider for the next seminar, especially the data access. This, I think, is a major issue in almost all the countries that we've spoken to. And so this is probably a topic that we can consider for the next webinar. But I look forward to receiving more feedback, Renee, from you. Otherwise, Ayumi, Frederick, Thomas, Alpha, Dr. Raj, if you have anything to add. We also have another area of statistics that we have a handbook or a guide, which is on migration. I don't know if our colleagues from Geostat is online, if you would like to take the floor and say something about migration statistics. Yeah, I can see Mariana from Geostat with her hand up. Can you unmute?
Now I can. It was disabled, the button. Can you hear me?
Yes, yes, I can hear you with a bit of noise. Can you try again?
Yes, there is some background noise. Sorry, because we have preparatory works for the upcoming census, and there are many of us in the room. Sorry. Can you hear me?
Yeah, we can try. Yes.
Okay, so first of all, thank you very much for this meeting. It was very informative. There were many interesting presentations. As from our side, couple of words. Can you hear me, or is there still some background noise? Sorry.
Yeah, there's still some background noise. Maybe if you can speak closer to your microphone, it will help.
Yes, I'm trying. Okay, so a couple of words about our handbook, or if there are any specific questions you could ask. Yeah, so thanks to all the institutions and the organizations, by the way, for their inputs and contributions to the handbook. Yes, so it's available on the wiki, the final version. Unfortunately, we do not have case studies on Georgia, but we have their algorithm, the detailed algorithm on the data processing in the part of internal and international migration, and the experience that our country accumulated, and also some literature review part in the part of migration statistics. So everyone who is interested could have a look on this handbook, and in case of any questions, feel free to ask questions or email probably. And if you have some questions right now, you could ask. And sorry again for the background noise.
Thank you so much, Mariana. I think what I'm doing here now is I pasted the link where you can find all the guides, and you can explore also the one on migration statistics along with the other areas of statistics that you heard today. I would also want to comment on the last question that we received on receiving the algorithms, so that they would know the type of data that the country would need to collect to be able to analyze MPD. So again, please consult the guide where the different information on what types of data are necessary for each of the use cases. They are listed in every of the guides that are available in the link that I just pasted.
And also, if I may add, on our current progress, so to say, till the end of the year, it will be more clear whether, as you are aware, our project is still on hold. So until the end of the year, we will figure it out whether there will be any progress in the future, in the perspective. It would be good because we have our regulator has access to all three mobile network operators' data, which is in some country is limitation. So we have access to all the our regulator, not Eurostat has access to the data, and probably if we will tackle our issues, so overcome those problems in the future, then we would have some progress further. Yeah, unfortunately for now, we don't have it. Thank you.
Thank you, Mariana, for sharing that. So I think with the 2 minutes left, I would like to wrap up and thank all the speakers and all the participants who shared their questions, and I think those are very important for us in terms of moving forward with the work of the task team and the future webinars that we would like to offer, not just for this region, but also for the other regional hubs. I think our line with regards to the different area of statistics are open for you to reach out, and the task team is also open to countries to take part, to share their experiences in any of these areas that we mentioned to you today. And of course, we would like to also hear from you if you would like to implement a pilot case in any of these 6 areas that we covered this afternoon. And we would like to also hear, whether in the future seminar we can address some of the challenges that you mentioned today regarding the data access and the infrastructure and skills. So I think with that, Renee, I turn it back to you and thank you for organizing this, both to FCSC and other colleagues in the UAE for facilitating this event. We will be back hopefully in the coming months with more information related to the use of mobile phone big data. Thank you very much, and over to you, Renee.
Excellent. Thank you very much, SB. I also just wanted to thank everyone on behalf of the UAE Regional Hub for attending the session, and just ask that you keep a lookout for the next session, which will be on the 23rd of November. We will be showcasing the work done by the Scanner Data task team, which I think is also going to be a very interesting session. So it will be great to see everyone there. Otherwise, thank you very much, presenters, and thank you very much for the participants, and have a wonderful day, evening, depending where you are. Take care and goodbye.
Thank you so much.